Good morning, Algebra 2. We are going to cover lesson 86, translating sine and cosine functions. And I'm going to make sure to scan the parent functions of each graph because it's really helpful to know how to translate these if you know what they're supposed to look like. So this is from a prior lesson, but I will attach this. And you really want to pay attention to where sine starts, which is at 0, 0. And where cosine starts at 0, 1. You really want to pay attention to these points because that is the main point we are going to move. Okay, so I will make sure to attach this in this section. So there are two ways to translate a graph. The first is a horizontal shift. Now, horizontal shift is going to be dictated by what is occurring in the parentheses. So H is going to shift our graph horizontally, which means it's either going to shift that initial point, this point here, to the left or to the right. So it's literally just going to move our graph either to the left or to the right. The second type of shift is a vertical shift. Now notice for this, it's represented by K and not V. I'm not sure why they chose K. But it is not going to have parentheses, okay? So that is the thing to really pay attention here, is a horizontal shift should occur inside the parentheses next to X, where a vertical shift will be on the outside. And a vertical shift is going to either shift your graph up or down. So again, paying attention to these, it's going to move our graph either up the y-axis or down the y-axis. So we're going to actually practice this by doing the lesson practice. So lesson practice for lesson 86, I don't have the page number next to me. And for all of these, we are going to describe, translation, and graph. So part A, y equals the sine of x minus pi radians. So the first thing I notice is this is inside the parentheses. So this is a horizontal shift. So this is h in this case equals pi. So this is a shift to the right, pi radians. And then I'm going to show you how I graph it using this knowledge. So here we go. I'm going to draw, here's the x-axis. And I'm going to use, here's pi, here's 2 pi, whoops, 2 pi, 3 pi. This is negative pi, negative 2 pi. I've kind of shrunk our graph from what is on the other one. And here's 1, here's negative 1. Okay, so using a pencil, I'm going to trace my parent function. So sine should be, it should go through pi and 2 pi. So here's this. So it should go up, it should go through pi, and it should go through 2 pi. And we don't need a very large graph. So here's the original, right? Here's this nice, pretty, it doesn't matter how you space it, but it would be nice if you used graph paper. Now I'm simply going to take this and shift each point to the right to pi. So I'm going to switch this point and just move it here. So notice I went 1, 2 boxes, so I'm going to move this one 1, 2. I'm going to move this one 1, 2, this one 1, 2, this one 1, 2, and so on. So I'm just moving each of the original points to the left. And then I'm going to connect them. Remember, they form like these nice little mountain looking or waves. And you don't need a ton, so I'm going to leave it like that. So this graph was shifted to the right, pi radians. Part B, So b is y equals cosine x plus 2 pi. Okay, now this is where it's a little tricky. I'm going to move this up a little bit. And there's a glare, and I apologize. So in this case, h is negative 2 pi. So notice h should be opposite because the standard form is x minus h. So in standard form, h is just pi. Here, h would be negative 2 pi. So that way, if I put it back in here, it'd be x minus a negative 2h, which makes it a positive. So this is a shift left 2 pi radians. So that's the description. Now notice this is cosine, so I'm using this graph. So this graph starts at pi and crosses at pi over 2 and 3 pi over 2. So here we go. I'm going to draw the original with pencil, and then I'm going to shift the graph. That is what I find to be the easiest. If you don't, great. So pi over 2, pi, 3 pi over 2, 2 pi. You can space it out however you like. You can space it out the same as mine. It's really up to you. So here's 1, negative 1. So with a pencil, I'm going to draw the original. The original should go through pi over 2 and through 3 pi over 2. So I'm tracing the original lightly with a pencil. And then I'm going to shift each point the number of radians according to the equation. All right, so this is left 2 pi. I didn't even put on here 2 pi. So I'm shifting this point here all the way to 2 pi. Okay, so that was 2, 4, 6, 8. So I have to shift each point 8 units. So 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8, and so forth. So I get the graph's going to look the same. It just got shifted. In fact, it'll look identical. Sorry, I'm trying to connect everything. And notice it still crosses where it should, and that's because of the repeating pattern. So even though it got shifted 2 pi radians, my peaks are still at the same places. So it looks the same. All right, moving on to part C. So y equals sine x minus 3. Now there are no parentheses here, and so I know that this is a vertical shift. And if it helps on here, left would be a plus h, right would be minus h, down would be minus k, up would be plus k. If that helps you at all. So I have a minus k means my graph, minus 3, has been shifted vertically. It's been shifted down 3 units. So I'm going to draw my original and then shift each point down 3 units. So we'll make a really short one. Whoops. I should at least make it straight using a ruler. And I need to make sure I leave room for this to be moved down 3. So let's go ahead and go pi over 2, pi, 3 pi over 2. So it'd be negative pi over 2. This honestly takes the longest, is just shifting everything. So I'm going to trace the original according to sine. My graph should look like this. So it should cross here. I'm going to just draw the original. All right. And then I am going to shift each point down 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then you'll start to see a pattern. So here is my new graph. So I just shifted each one down. Okay. All right, moving on. Y equals cosine x plus 2. So this is a really simple one, right? This is just up 2. So cosine cosine should cross, and here's 1, 2, 3, 4. Here's pi. Here's 2 pi, negative pi, negative 2 pi. So cosine should look like this. But I'm going to shift each of these up to the 2. So this would go up 1, 2, up 1, 2, up 1, 2. Keeping in mind our spacing. You could also use Desmos, and then you'll start to see a pattern. And so here is my graph. How pretty is that? All right, next one. So then this is the last one we will do. And let's see if I can fit it. So E is y equals sine of x plus pi minus 2. So this has both. So I know that this has been shifted left pi radians and down 2. And this is sine. So I'm going to draw the original. Okay, so here's 1, here's -1, -2, -3. Let's see here. Pi, 2 pi, negative pi, negative 2 pi. Okay, so sine should look like here, 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 here. Notice I have more than one transformation. So I'm going to lightly trace this in pencil so you can see me do both. And I guess if you print the parent graphs, you could just put it underneath and literally trace this. All right, so I have to shift each point left pi units and down 2. So this point here would go to pi and then down 1, 2. Okay, now I'm going to do this one. Go, pi is 4 boxes away, so 4 and down 2. 4 and down 2. 4 and down 2. And then I can kind of guess based on the spacing where everything should be. And so now my graph, I'm going to try to do this very beautifully. You could also write all of your thinking. I'll just put this in Desmos. Oops. And there is our graph. Isn't that beautiful? We are not going to do F and G. Parts F and G you can do on Desmos. Thank you.